Hi, welcome back. In the previous video, we've looked at creating and altering views. In this video, we will look at the attributes we can specify when creating views. The first attribute we will cover is the encryption attribute. When we create a view, the definition of the view is simply stored in the database. In the previous video, we saw numerous ways we can retrieve the definition of a view. However, if the view is created with the encryption attribute, the definition of the view will be encrypted and will no longer be accessible. Next, we have the schema binding attribute. This attribute binds the view to the schema of the underlying objects. As a result, these objects cannot be modified in a way that would affect the definition of the view. This creates a dependency between the objects. Normally, when we create a view, you can modify the whole structure of the underlying objects. Even dropping the underlying objects can be done. The results of these schema modifications will only come into play when we query the view. The view can then either return unpredictable results or complete with errors. This is where the schema binding attribute comes in. If we use this attribute when we create or alter a view, the structure of the underlying objects can no longer be modified in a way that affects the definition of the view, for the view is now dependent on these objects. This is a requirement when creating indexes on views. We'll cover this attribute in more depth later on in this video. The next attribute we have is the view metadata attribute. This can be very important if the view we create will be referenced by APIs such as ODBC, OLEDB, or DB library. The view's metadata is information about the view's properties. This includes the names of columns and their data types. To display and manipulate the data, the API will need to know as precisely as possible the structure of the objects it will be using. Normally, when we create a view, SQL Server queries the tables that make up the view to retrieve and return the metadata from the base tables. This makes it impossible to create updatable client-side cursors based on the view. To fix this, we can create or alter the view with the view metadata attribute. SQL Server will then no longer query the base tables. Instead, it will send the view's metadata back to the client. The view is then seen as a single table. This allows us to create updatable client-side cursors based on the view. This view attribute is not frequently used, but it's good to know that it exists and what its purpose is. Last but not least, we have the check option attribute. This attribute can add a level of integrity when manipulating data through a view. Views can be updatable depending on how we design them. This means that we can run DML statements against the view and as a result manipulate data in the underlying base table. Views are most commonly used to return a subset of data based on predicates or conditions. When we give users permission to access and manipulate data through the view, the users will be able to perform data manipulation that can violate the conditions for which the view returns data, especially insert statements. When we insert data through a view, the data can be inserted regardless of whether it satisfies the logic of the view. As a result, we can have data inserted through the view which will not be retrieved by the view. This can cause integrity issues. Update statements can also present the same issues. By updating data through a view, we can change the fields of the rows returned by the view in a way that the view will no longer retrieve them. This is where the check option comes in. If we create or alter a view with the check option attribute, any data manipulation performed against the view needs to satisfy the conditions defined by the view, and thus creating a certain level of consistency. Let's head over to the SQL Server Management Studio to look at some practical implementations of these attributes. We'll first start with the encryption attribute. When we create views, stored procedures, or functions, the definition of these objects, including their metadata, gets stored in system tables. This information can then be retrieved by using information schema views, system views, and system stored procedures, as we've seen in the previous video. This makes altering these types of objects relatively easy, because we can easily access their definition. However, sometimes you might find yourself working with highly confidential code. This is where definition encryption or source code hiding might be an option. To hide the definition of view objects, we simply specify with encryption after the name of the object. If we now alter the view, the definition of the view will be encrypted. If we execute the help text system stored procedure, we no longer get a result set with the definition of the object returned. Instead, we get a message stating that the text for the view object is encrypted. If we try to script the view as alter to a new query window, we still won't be able to access the definition of the view. As you can see, we get an error because we're trying to access an encrypted definition of the view. While it may not seem dangerous, careless usage of this attribute can leave you stuck with your head in your hands. If for any reason we lose this copy of the view's definition, we can no longer manage the view because there's no straightforward way to decrypt the view's definition. So it's very imperative that you store the view's definition somewhere safe when using this attribute. This is the primary reason I don't recommend the use of this attribute. There are definitely certain use cases for it, but it's a lot safer to control this by using security principles and permissions. This way, it's always possible for an authorized user to access the definition of the view, in case it needs to be managed. To remove the encryption from the view's definition, we need to alter the view, but this time without the encryption attribute. If we execute this DDL script, the encryption will be removed. If we now execute the help text system stored procedure, it correctly returns the definition of this object. Next, we'll look at the schema binding attribute. Before we cover this attribute, we're going to create a copy of the employee table in the DBO schema. Once the table is created, we'll use a merge statement to copy the data from the employee table on the sales schema to the employee table on the DBO schema. If we now query the new employee table, you should see the data we just inserted using the merge statement. We will now create a fairly simple view that references this table. If we query the view, we should see a similar result set returned. The next thing we'll do is change the structure of the underlying base table. We will use the SP rename system stored procedure to change the name of the active column to status. If you are unfamiliar with this stored procedure, you can see the context-sensitive help by simply pressing Shift F1. This will open a web page with full documentation about the object. This is a handy feature you can use to view the documentation of objects or commands you're not familiar with. Let's go ahead and execute this procedure. If we head over to the Object Explorer, we should see the changes we just made by executing this stored procedure. As you can see, the name of the column is successfully changed to status. However, when we query the view, the name of the column remains unchanged. This query completed without errors because we've used the asterisk instead of explicitly referencing the column by name. Even though there is no error thrown, the view is still out of data. This can of course be an issue, especially if client applications are now specifically looking for a status column. To fix this, we will use the SP refresh view system stored procedure to refresh the view. If we execute this statement, the view should be refreshed. If we query the view, you'll notice that the name of the active column is now successfully changed. Let's try to drop the status column from the underlying base table. If we query the view again, you'll notice we get an error. This error can also be resolved by simply refreshing the view. As you can see, the status column is not returned by the view. There are certain restrictions to using the SP refresh view stored procedure. If we, for example, drop the underlying base table or explicitly define the columns instead of using the asterisk, the refresh view stored procedure will not be able to refresh the view. Let's go ahead and explicitly define the columns in the select statement of the view. Since the view already exists, we need to replace the create command with the alter command. Once we're done, we can execute this DDL script to alter the view. Let's go ahead and drop the phone column from the underlying base table by executing the following DDL script. If we now try to query the view, you'll notice the following two errors. These errors are a result of the views trying to access an object that no longer exists. Even if we try to refresh the view, it will not solve the problem. The view is at the point rendered broken. You'd have to manually alter the view to accommodate these schema changes. Let's go ahead and alter the view. This time we will include the with schema binding attribute. Let's execute this DDL script to alter the view. If we now query the view, we get the expected result. Let's try to change the name of the email column to email address. If we execute this procedure, we get the following error. We get this error because the object we're trying to rename is participating in an enforced dependency, which is what the schema binding attribute created on all the underlying objects. If we now, for example, try to drop the email column, you'll notice a similar error appearing. So, this gives a better understanding of how the schema binding attribute behaves and why it's important, especially if you have objects that are being referenced by multiple objects. If you change the structure of the underlying base objects and forget to accommodate these schema changes in the referencing objects, you might break several scripts. So this is one way to prevent these types of mistakes. This is, however, not the ideal way of using views. Views should generally be used as a data access layer. Instead of giving users direct access to tables where the actual data is stored, we should give them access to views and stored procedures. These objects will then behave as the data access layer. If requirements for client applications change, we can easily implement these changes in the data access layer instead of the table itself. This process is called loose coupling. If we change the structure of the table, we have to modify every object that references it, or we might break existing procedures. However, if we only apply changes to the data access layer, we no longer have this chain of dependency, and the chance of scripts breaking because of schema changes is heavily reduced. We can then use the schema binding attribute to enforce that the underlying objects cannot be changed in a way that alters the definition of existing scripts. Later on in this course, where we cover indexed views, we'll be using this attribute again. Last but not least, we'll look at the check option attribute. To cover this attribute, we'll also create a different view. This view will display only customers from California. Everyone working at the California shops will be giving access to this view instead of the customer table. This way, they'll be able to look up existing customers or register new ones specific to their region. This view, however, is not safe-proof. That's because someone from the California shops could accidentally register a new customer from New York or any other region. This can be seen when we execute the insert statement. If we query both the view and the underlying base table, you'll notice that the view did not return the newly registered customer because the customer doesn't comply with the conditions defined in the view. The customer is only returned in the result set of the underlying base table. The point is to have every shop manage the customers in their own state. Being able to insert new customers who are not from California through this view violates this requirement. Another issue is updating customers. Employees from the California shops can update the state or region field of a Californian customer. This may cause the view no longer to retrieve these customers. This update statement updates the state of a Californian customer to New York. If we execute this statement, you'll notice the query executed successfully. If we query both objects, you'll see that the view no longer retrieves that particular customer. Let's update the state for this customer back to its original value. Since the view no longer returns this customer, we have to use the underlying base table. So we've now seen two issues with this view. To fix these issues, we will alter the view with the check option attribute. Unlike the previous attributes we've covered, the check option attribute is added at the end of the select statement. If we execute this DDL script, our view will be altered. If we now try to insert a new customer who is from New York through the California customer view, you'll notice we get the following error. We receive this error because the insert statement violates the condition defined in the view's select statement. If we try to perform an update statement that changes the state of a California customer, you'll notice we get the same error, and that's because the update statement tries to update the customer in a way that the view will no longer retrieve it. As with update statements, delete statements can only affect the rows returned by the view. Since delete statements don't perform modifications, they are generally safe within the context. If I, for example, try to delete customers from other regions through this view, the query will result in 0 rows affected, because the view only returns customers from California, which means that we can only delete customers from California through this view. The view is now safe-proof. This is an effective way we can manage row-level security and improve consistency, especially if we have multiple principals who use the same underlying base table. However, in SQL Server 2016, Microsoft introduced row-level security, which is a feature that enables fine-grained control over access to rows in a table. This goes beyond the scope of this course, but you should definitely check it out. That's it for view attributes. Thank you for watching. In the next video, we will look more thoroughly at updatable views. See you then.